Okay, on to the next page. Okay, here we've got an XY table. And remember that these are just ordered pairs. Okay, so the 0.13, the 0.25, the 0.37, and so forth are going to be on this function, whatever it is. So what type of equation fits the data? Would it be a line? Would it be a parabola? Would it be something else? Well, there's a nice little test you can do. If your x coordinates are evenly spaced like mine are, so I'm jumping 1 unit to get from it doesn't have to be, you could be counting by twos or something, but you'd want them to be evenly spaced like that, like they are, and ordered. And if they are, then we can do a quick little test to figure out what type of equation is going to fit the data. And what you want to do is think, well, what are you adding or subtracting to get from one y to the next y? And in this case, I'm just adding 2, right? Okay, and notice I'm going to be adding 2 on every one of those. So this is called the first difference. And when the first difference is, when I have a common first difference, so that means that first difference is coming the same out every time. I've got a common first difference. So, if I was adding 2, then 3, then 5 or something, that wouldn't be in common. But it's adding 2 every time. When you have a common first difference, then it's going to be a linear equation. Okay, so that means this data will fit a straight line. Okay? So if we wanted to write an equation to fit all of this data, you could just take 2 of the xy pairs, and then you could find the slope. You'd have a through point, so you could start with point slope form and work from there. You can also use a calculator to do it. We can input this data into our calculator using the stat menu. Okay, so that's what I'm going to do here. So the stat menu on a TI graphing calculator is usually up here, that stat button. That's what I'm going to start with, okay? And I want to edit, okay? And I've got these, it has more than 2 columns, but we're only just going to input things into the first 2 columns. So if you've got other numbers in here, especially if you've got things in list 3 or list 4, erase those, okay? So you can just go on entries and hit clear for each entry to do it. There's quicker ways to do it, but that'll work for now. Okay, I don't have anything in there. So this is an XY table, so this is going to be my X's. I'm going to put my X's in list 1. So I'm going to type 1, enter, 2, enter, 3, enter, 4, enter, 5, enter. And those are my X's, right? It can't list it horizontally like this, so this is just how it's set up in this calculator. And then I'm putting my Y's in list 2, 3, 5, 7, 9, 11. Okay? All right, and you don't need to go back to the home screen. You can if you want, but if you go back to the stat menu now, I'm going to hit the stat button again, and I'm going to go over to calc. I'm going to do a calculation with the statistics that I just saved in my calculator. Okay, now this is going to be, I'm going to do a linear regression, which means my calculator is going to take that data and write an equation of a line that fits that data. So I want to go to this one, linear regression, because I know that for this data, this should fit a straight line, okay? And so I'm going to type that, and that's just pick the program. Now I'm going to hit enter again to actually run it, okay? And they're telling me, oh, okay, I've got an equation in this form, and then they tell me what the A and the B are, which is what I really want to know, right? So A here is 2, and B is 1. And so you could try it out. Those XY pairs should work. When I plug in 1 for X, I would get out 3 for Y, right? When I plug in 2 for X, I get out 5 for Y. So it does work with all those points, okay? It's a nice quick way to write an equation from data, okay? But what if we don't have a straight line? So let's look at this one. When I'm looking, what am I adding to get from point to point? From Y to Y, I would need to check my Y's, see how my X's are evenly spaced. So that's good. Okay, so let's look at the Y. So I'm not really adding here, I'm subtracting 3. Well, you could think of that as adding -3 if you wanted to, okay? And then I'm subtracting 1, but now all of a sudden I'm adding again, and I'm adding 3. So the first difference isn't in common, so that means a straight line is not going to fit this data, okay? So when that happens, these are my first differences. I want to check my second differences. So now I want to check the differences between the differences. So I want to see how am I getting from difference to difference. And I'm thinking, what am I adding or subtracting? Well, -3, I'd have to add 2 to that to get to -1. From -1, I'd have to add 2 to get to +1. And hey, look at that. So my second differences, so I have a common second difference. And when that happens, I'm going to have a second degree equation, which is a quadratic function, right? So if the first differences are common, you got a first degree equation, which is linear. And if you got a second degree or second common second difference, it's a second degree equation, and that means you'll have a squared variable in there. So this is going to be a quadratic equation or function, however you want to say that. Okay. So you can repeat the test with if the third difference was in common. I mean, we've already determined this is quadratic, but you could repeat that. You can keep going down the list. So you can do this test to find third degree equations or fourth degree or whatever. We don't really have enough data for that here. You need a bigger XY table, but you can repeat that process and look at the third differences. Yeah, the third differences are all 0 here, but we've already determined that this is quadratic. Okay. All right, so let's do a regression here. It's the same kind of deal, so I'm going to go to the Stat menu. I'm going to go to Edit. Okay, now I want to clear this data, and a quick way, instead of clearing the entries one by one, if I just go highlight L1 at the top and hit Clear and then Enter, it erases that whole list all at once. And I still want to erase my Y's too, so highlight L2, hit Clear and Enter. Now I'm starting from scratch, okay? And when you type the negatives in, make sure you use this negative, not that one, right? This one, okay? We're not subtracting anything. We're just telling our calculator this is -2, enter, then -1, 0, 1, 2. There's my x values. Okay? So, got those in there. I'm going to go to Stat again. And calc to do a calculation with that stuff. Okay, last time we did linear regression, but this isn't a straight line. I want to do a quadratic regression. And if you had a third or fourth degree equation, you do cubic regression or quartic. We don't have to do that yet because we haven't gotten to those. But quadratic equation, and I'll do my regression. Okay, and this is saying I've got this format. Whoops. And then we're told what A, B, and C are, right? So A is 1, B is 0, and C is 0. So you don't have to write the 0 terms. I've got this, which actually makes sense, right? If you take the x, any one of these x's and square it, this is our parent graph, right? Okay. Oh yeah, and I forgot to say the last thing we're doing here is quad regression for quadratic regression, okay? Another way you can get around this, if you're not using a calculator, we could write an equation using any 3 points that are on this parabola. So those are xy pairs, right? So at the beginning of 2.4, we learned that you could plug those into standard form and then find the A, B, and C and write it that way, and that should get you the same result. Okay? I think it's quicker to do it with your calculator with the stat function, but you can go either way. Okay, I want to talk about different ways to represent sets of numbers. So here I've got an inequality, okay, and this means it's everything from 3 to 7, right? The 3 is included, the 7 is not included. Okay, so hopefully you're familiar with that. Okay, so let's write this as an inequality. So if I'm using x to represent all of these numbers, it goes from 3 to 7. So I can say, I can put the least number there, right, and the greatest number there. So it's going to be, x is going to be a number greater than 3, or I could say 3 is less than x, or it could be equal to 3 because 3 is included. So that's why I've got that underline there, okay? And then x is also going to be less than 7. So this is a compound inequality. You could write it as two different inequalities with a comma, but I like to just put them together like that. So it's everything from 3 to 7, 3 included, 7 not included. This means the same thing as the graph above, okay? Interval notation is something different. With interval notation, what you do is you give the bounds. So this goes from 3 to 7. So I just put my least value and my greatest value, okay? And I still want to indicate which one of these is included and which one isn't. So the way I do that is with different types of brackets, okay? So if you've got a square bracket, this means included, and then this would mean not included. Okay, and then we've got set builder notation. I don't use set builder very much, but you'll see it occasionally, so it's worth knowing how it works. Okay, so we've got these fancy brackets like that, and then it's always going to start like this. So this means x is a number such that so if I were to read this out, that's what that part means. X is a number such that, okay, and I wouldn't write that out normally. I'm just explaining what this means. Is a number such that, and then I'm going to write this inequality. You could also, you know, if you've got like an equation, 2x plus 3, you could put something like that if you wanted to build your set that way. But this I'm just showing it's that range of numbers from 3 to 7 with 3 included, 7 not included, okay? All right, so let's try this set. So this one is only bounded on one end. So this line indicates that it goes off forever towards infinity, okay? So this is positive infinity over here. If you went to the left forever, negative infinity would be over there. So those are kind of, just think of those as directions. Positive infinity is to the right, negative infinity is to the left, okay? So as in an inequality, the x is just going to be a number greater or equal to 3. That's it, right? There's no, it can be any number greater or equal, can go up towards infinity, okay? In interval notation, when I'm showing my lower bound, it's 3, and that is included, right? I've got a closed dot, just like on the previous example, okay? And there is no bound going to the right, so this can go all the way to infinity, okay? Now, here's an interesting question. Is infinity included or not included? Well, it's not an actual number. It's more of a direction. We'll never reach infinity, but we can keep going up forever. So infinity itself is actually not included, okay? One way I remember that is that bracket kind of fits nicely on the curve from the infinity symbol. And so there's interval notation, okay? So set builder notation is going to be pretty similar to what I had in the other example there. X is a number such that, and then I'll just use this inequality. X is a number such that x is greater or equal to 3 is what this means, okay? All right, let's talk about domain and range. So the domain is going to be all of the possible x values in a given function or set of numbers. X values. And then the range is all the possible y values. These are alphabetical, right? D comes before R in the alphabet, X comes before Y, so that's how you can remember which is which. All right. So let's find the domain and range of this equation, okay? There are ways to do this algebraically, but this is just a parabola. So I think the easiest way to do this is going to be to sketch a little picture. So this is going to have a vertex at 2, 3. Okay, so 2, 3 is right here. And I can see it's going to open upwards And there's no stretch or compression, so the next 2 points would be up one to the right, one up one to the left one. And there's my parabola. Okay, there's a sketch of my parabola. So let's think about all of the possible x values. Well, this parabola is gonna, those arrows mean that it's gonna go up forever, but also it's gonna be stretching out forever. Now it kind of will feel like it's getting steeper and steeper. It is getting steeper and steeper, but it's still gonna stretch out each way to the left and right. The further you go up, the wider the parabola is gonna be. That will happen forever. It'll go slower and slower, but it's still going to be stretching left and right forever. So the domain is all the possible x values, and this can go all the way from negative infinity to positive infinity. It can stretch out left and right forever. Okay, so when I'm listing the domain, I'm just going to say that this is all real numbers. Okay, and you can write out all real numbers, or you can use this fancy uppercase R, and that's supposed to mean all real numbers. Okay, you could also use a different way to express that set. You could say it goes from negative infinity to positive infinity. But I'm just going to say all real numbers for the domain. Okay. Now the range are all of the y values. So I'm thinking, how far up and down do the points go? What's my lowest point? Well, my lowest point is going to happen at the vertex. Okay. But I'm really only interested in the height. So this is my minimum value is going to be 3, right? So that's my lowest y value. It can be anything greater than that because the y's are going to go up from there. So my range is going to be any values 3 or greater for y. So those are talking about my y values, so I want to show that the y's have to be greater or equal to 3. And again, you could use a different type of notation if you like there. Okay? Okay, on the next page, we've got 2 more examples where I'm looking for the domain and range. And the easiest way by far is to find the vertex, I think, when we've got a parabola. Okay? So that's what I'm going to do on these next 2 problems. So looking at my first one, hey, this is in standard form, so I can't just see what the vertex is. So let's find the vertex by using the axis of symmetry formula. Right, there it is. X equals negative b over 2a. My b would be 6. My a is 3. So x equals 1 is the axis of symmetry. And that is also telling me the x coordinate of the vertex. And then I still need to find the y that goes with that. So back in the equation, I'm going to plug in 1 for x. And then solve this. So 3 times 1 is 3. So I've got 10. Okay, now I'm not going to sketch a real graph here. I mean, not a fancy graph, but I am thinking, which way does this parabola open? Well, it's a positive a value, so this is, and it's a y equals 1. So it's going to open upwards, okay? So my parabola is going to look something like this. Now, I'm not putting this on an xy axis again, but I do want to think, okay, it's going to open upwards from 110. So my domain, this is my x values, can go left and right forever. So the domain, again, is going to be all real numbers. Okay. The range, they're going to go up from my lowest y value, from my minimum value, which is 10. So my y's are going to be greater or equal to positive 10. Okay. All right, let's try this next one. So this one is in vertex form, but we got to be careful here. It's in x equals. So this isn't. This is this kind of deal, right? It's in vertex form, but it's one of those. Y equals x squared or y equals negative x squared are going to equal up, open up or down. But the x equals 1's open left or right, and this particular one is going to open to the left. Okay, so be careful here. All right, so I'm going to have one that's opening to the left, and I'm interested in what the vertex is because those are going to be the extreme values one way or another, okay? So it's tempting to say that the vertex is 5, 1, but that's incorrect, right? Because I got to think, oh, that 5 is attached to the y. So this is going to give me the y coordinate of the vertex, and this is going to give me the x value. And since the y is already spoken for. So the vertex is going to be 1, 5, not 5, 1. Sorry, I'm off screen there. Okay, so I'll put that in my little sketch here. Okay, and then I'm thinking, all right, domain. Oh, so this is interesting. This time the domain is going to go, well, it's going to go to the left forever from here. So this is going to be the maximum x value, right? The maximum x value is going to be 1, and it's going to go to the left from there. So this time my x's have to be less than or equal to 1. Okay, that's my domain. And then the range, I'm talking about the y values, and the y values don't have a maximum because this goes up and down forever, right? It's going to get wider and wider as we go out to the left. So this time the range is going to be all real numbers. There is the domain and range. Okay, that's it.